All right. Welcome, everyone, to our second session of the day. Today's session is a panel from Mila Rosenthal, Matthew Mckenzie, Daniel San Martin, and Campbell Watson. And they'll be talking to us on a recorded session about bridging the data analytics divide for climate disaster preparation and action. So Mila is our panel representative, and she joins us. She is the executive director of the International Science Reserve at the New York Academy of Sciences. There, she manages a global network of researchers, technologists, and scientific institutions to prepare a response for climate disasters. She currently also teaches at Columbia University as an assistant professor of international and public affairs. Mila is the co-founder of the climate campaigning organization Planet Reimagined, previously as the director of communications and advocacy for the United Nations Development Program. Dr. Rosenthal has spearheaded public policy advocacy across 170 countries for the UN's lead sustainable development agency. She held the executive positions at Amnesty International, Health Right International, and Concern Worldwide, as well as worked in countries in Africa and Southeast Asia. We are very, very privileged to have Mila and the panel joining us today. And with that, I will hand it over to Nadine to start our recording of this panel session.
I'm Mila Rosenthal from the International Science Reserve. Today we're going to be talking about bridging the digital divide, and we're very thrilled to have my fellow panelists here with me today. I'm going to introduce in order as we come into the discussion. First, Campbell Watson, who's just joined us, Matthew Mckenzie, and Danielle San Martin. Thank you all for joining me this morning. All of us today are associated with the International Science Reserve in different ways. And what we're going to talk about today is different issues in looking at access to data analytics, data modeling in times of crisis, and particularly around climate-linked crises and in response to prevention, risk, and climate response to climate-linked crises. The International Science Reserve is an initiative of the New York Academy of Sciences. It's an international network of scientists and technologists from disciplines and domains across the spectrum who are interested in responding when the next global disaster of a truly large global scale that is extremely complex and that requires cooperation, huge amounts of international cooperation to respond to. The International Science Reserve obviously grew out of the experience of the pandemic, where we saw that the challenge of both in some ways a very fast response from the scientific community in many ways, and in other ways a lot of people and institutions who wanted to be involved, who wanted to help, and really didn't have a way to connect. And so the idea of building a platform for collaboration for scientists and institutions to be connected in advance and to be thinking in advance about preparing for crisis came out of that. There was also an experience during COVID of scientific institutions that had resources that they wanted to make available to help, and we're also looking for ways to help. IBM, and my colleague Campbell Watson from IBM is here today, was one of the companies that was in that situation. IBM had, as they looked at the pandemic and said, well, what can we do to help? One of the huge resources they had was high performance computing power that they wanted to make available for running research and testing and modeling for anything that would be useful for response to COVID. And they were part of the founding of something called the High Performance Computing Consortium, in which they joined other U.S. companies, the U.S. government, and NSF, and very quickly put together a system where researchers could apply for access with specific projects, and ran about 200 COVID-related projects in a few months. So the International Science Reserve is part of thinking of resources like that in advance. And certainly when the next big global crisis of that scale hits, access to data analytics and modeling data sets is going to be key. And that's across all kinds of climate-linked disasters. And we'll talk about some of the examples coming up. So far the reserve has been growing really rapidly. It's we just established last year. It's now over 5,000 scientists and institutions from around the world that have joined. More than half of them are from the developing world, from low and middle income countries, and contexts that are often the hardest hit by climate change and have the fewest resources to deal with them. The International Science Reserve, by bringing together those scientists and technologists and institutions from those contexts with different kinds of resources, is part of helping to think about bridging that data divide that what brings us together today. Campbell, I'm gonna start with you to open this conversation. Campbell is a leader in climate and sustainability science at IBM Research. Has been involved in the International Science Reserve since its beginning over the last year. And Campbell, you are an expert in climate science and in thinking about the use of data and modeling. I know that you've worked on most recently on, for example, measuring greenhouse gas emissions, and I would love to open up by asking if you could talk a little bit about how IBM has approached your thinking about the role of data and modeling in response to climate and in preparing for dealing with climate change.
Yeah, absolutely. Hi, everybody. Thanks so much for inviting me today. It's a real pleasure to speak with you all. Yeah, so I help lead a team of around 40 research scientists at IBM Research, and we've been building for the last few years software and technology. A lot of it's focused using geospatial data and AI to try and extract really meaningful information and insights from that data coming from satellites, coming from weather models and climate models, and then of course just network sensors and so forth that are spread across the globe. And the work is, our core focus is building the technology that enables the insights to be made. And in so doing, we handpick a few select applications to demonstrate the value of it. And so one of them, as you said, is related to carbon, and specifically, so carbon sequestration from trees, and also emissions, methane emissions from, it could be abandoned gas wells or leaking gas line pipes. And so this is using a lot of satellite imagery. And what we've known through years of working with geospatial data, and it's just one of the most common challenges that organizations face when working with geospatial data, is that it's huge, vast. It's terabytes and petabytes of data. It's located all across the world and it's owned by different organizations. So bringing that data together and providing it in an analysis-ready format is highly valuable. This is work that happens across the globe already by many of these institutions, and it's something that we're also taking part in. But going beyond that, it's also providing the tools to then analyze it. And so a big focus of ours in the past year has been the paradigm shifting, large AI models that many people would know about in the context of natural language. So these large language models, we've been doing the same sort of thing in collaboration with NASA, building these large geospatial models. So again, using transformers, which are a form of a neural network, to develop these models that can take, say, satellite imagery, and they can be what we call fine-tuned to derive a certain insight from it. So some work that we've recently been doing is trying to detect flooded areas from satellite imagery. And so this is particularly relevant for the ISR and response to disasters, to actually understand the full extent of floods, especially in regions where communications have been cut. And so it would enable, much more rapid response from folk on the ground to get the resources where they need to be. And so it's obviously not just flood mapping, it's also wildfires, methane emissions, and so for the whole range of climate and sustainability applications related to geospatial data and AI. So a real focus for us is, building this technology. And one of the great things about partnering with the ISR is that we're getting this technology into the hands of the people that can use it. And, we don't want people to just be a user of AI. We want them to be a value creator of this AI. So it's not just take this model and run it. You could use this infrastructure to build your own model to do a very specific task that's of interest to you.
Great. Thank you, Campbell. And I'd love to come back and talk a little bit more about that, about the examples that you've been applying that to,
Sure.
and that other researchers are able to apply that to. I'm going to introduce next Matthew Mckenzie. Matthew is a software solutions architect. Matthew, you have this amazing experience in decorated commission service in the U.S. Navy. And when I first, I think, talked to you, we talked a lot about meteorology and weather. You have that background in oceanography and environmental and geospatial analysis. And you have a special expertise in operational planning and decision making, and in the way that Campbell was talking about integrating AI and machine learning. You have been thinking about that in terms of operational strategic planning, and in preparing for measuring risk and in preparing for crisis. And I wanted to start by asking you about about crisis response decision making, and how data and the kind of work you've done feeds into that, and how you help decision makers prepare for intensifying climate crises and other kinds of crises worldwide.
Hi, Mila. Hello, everybody. It's really great to be here and to be a part of this discussion. Yeah, and thank you for that wonderful introduction. I think I've been very fortunate, and I bridge like an interesting gap myself in that I have a background in environmental science. I've got degrees in both physical meteorology and physical oceanography. I've also applied that in operational settings and operational decision making. And throughout my career, I spent a lot of time turning data and turning especially environmental information into products and presentations and briefings to support real world and planning decisions that were being made. And that spans across all kind of levels of decision making. In the military discussions, we kind of break that down into three areas: kind of the tactical, operational, and then the strategic. And those are kind of increasing in size as you move through those. As my career has gone on, I've watched kind of decision making from the various levels. Been in the room for the tactical, for the operational, and now really over the last few years for the strategic level decisions. And that's planning for crisis, but also for real-time crisis response as well. And my observations of being someone that has created the information to support decisions, and also being someone that's either making those decisions or being in the room with those decisions, is that there's a surprising disconnect between the work, the data, the research, the analysis, and what is actually being presented, or what makes it into the room, or what is considered. So that's really kind of evolved my passion for developing applications or tools or systems that can bring more of that work and bring more of all of these wonderful things that are being described by Campbell just now, and making sure that those are getting into the room, getting consideration. If we look traditionally at, what are the applications that support decisions? Well, it's PowerPoint, it's text documents, PDFs, Word documents, it's spreadsheets. The spreadsheets can be styled to look like dashboards, and the PowerPoints can be styled to be slightly interactive. But we're talking about very static and kind of manually intensive tools, in that they're hard to change, they're hard to be responsive in real time, or to incorporate complex or complicated data, especially when time for decisions is short. The other side of that is that I've seen is kind of hyper-specific tools, and those are static in their own way, in that they're static in the kind of the problem that they're able to look at. Their field of view is generally very small, and their configurability or their capability to be modified to address a different problem is either very minor or non-existent. So, if those are kind of our two options, and that's one of or the combination of those is resulting in us losing a lot of this expertise, losing a lot of this data, losing a lot of this work, and then our decisions suffering. How do we improve that? I've been fortunate to have a lot of experience with geospatial information systems, and that was kind of my first eye-opening experience to something outside of Microsoft Office product suite, or just text documents. And the extensibility there, and the ability to build tools, build systems that let you start layering complexity, and build interactive systems for people to interact with, and to be able to ask a question, see the visualization or the representation change in real time, and have that in the room for the people that are making decisions, so they can start doing what if scenarios. They can start asking if these parameters change, what does that look like? If this dam is holding back this much water versus this much water, what does the flooding model show us? How does that change the calculus of this decision? And that's kind of the bare minimum, I would say. Our technology stack, the things that are available to us and available to everybody with internet and computing access through open source projects and widely available tools, like that really gives us a lot of power to think about how to shape all of the data and information that's out there, and how to bring forward all of the outputs from the work that Campbell and Daniel and all of the research and development side of the house are doing.
Matthew, you mentioned scenarios and how that helps to in visualizing and bringing to life the data, and that is how I first met our next speaker, Danielle. Was a crisis scenario that we developed at the International Science Reserve that was looking at wildfires, and where we developed examples of three hypothetical, based on reality, but hypothetical large-scale wildfires across borders, and invited the members of the ISR network to think about what are the kinds of tools and resources they would use in responding to the wildfires. And Danielle had a really had some really groundbreaking thinking about it that that was really showed some new thinking that we were interested in. And I'm going to ask him to talk a little bit about that today. Daniel is just finishing his PhD at the Universidad Técnica Federico Santa Maria in Chile. And he specializes in scientific computing and his research is focusing on computational fluid dynamics, numerical methods, and high performance computing. And he's been applying it specifically to forest fire modeling. Daniel, can I ask you, when you when you first joined the International Science Reserve and in general in your work, can you talk about how you've looked for collaborations in global collaborations and what you found in looking for that kind of global network? And how has that helped you in facing challenges in access to data in your region in terms of wildfires and comparing it in terms of wildfires and knowledge and expertise and data sets in other places, and how that access to those other kinds of resources how can affect your research and your work?
Oh, sure. Hello, Mila. Hello, everyone. Thank you for the invitation to this panel. I think collaborating with a global network is crucial for developing countries like Chile. So we do this to tap into diverse expertise to gain a global perspective, specifically on disasters, and also to share resources, build the capacity, ensure rapid response. So I think different experts in disasters management approach these collaborations in order to conduct research, to respond to emergencies and shape policies. So I think these are some of the reasons why I'm looking for a collaboration in a global network. But in terms of data, it's a really challenging in my region because the availability in our country, we don't have the technologies or the money to get, for instance, satellite data with the resolution that used in US, for instance. So we have a lot of resource constraints and the remote sensing, for instance. So we usually try to use the data provided by US or European institution, and we use the data to create models, but this cannot always be applied because we have different geographical or meteorological difference. So, but I think it's a classical approach, but we need the data of the technology developed by other countries. So I think it's the main challenge with the data for us.
Mm-hmm. I'm wondering, Campbell, if when you started by talking about one of the problems with data is that there's so much of it and it's in different it's in different formats and it's in different places and so forth. And I'm wondering how you think about that in the problem that Danielle raised about what are the different ways to address it.
Well, Daniel, I can tell you that you're not alone. Being in Chile does not mean that you're the only one that experiences this. I can sit in New York City and have exactly the same problems. It's the community is doing a hell of a lot to address this challenge, in part because the amount of data that's being generated by satellites and by different models is exploding. And the community is also recognized. I mean, I think we recognized it a long time ago, and this cuts across academia, government, and industry, that you can't do this alone. So everybody is now working, in a very kind of open science, open standard method. So it's something we at IBM Research developed around over 10 years ago, a geospatial data platform for working with geospatial data. At the time, there really wasn't the amount of tools that are available today to work with terabytes or petabytes of geospatial data and harmonize it onto the same grid, because one satellite measures it at one resolution and projects it in a certain way compared to a different satellite. So the team that we've developed has a deep expertise and is very familiar with the different problems that across industry and government with regard to geospatial data. And today, we are really focused on partnering with organizations such as NASA and other government and private organizations to bring in, our expertise, not just in geospatial data, but also in AI to help them, and with their help, they help us as well to work more efficiently with the vast amount of data and apply new methods, especially in the field of AI, to it. So we have an upcoming project, for example, that are using some state-of-the-art AI methods as a form of compression of this geospatial data. So, there's existing methods of compression which have been around for a long time, such as when you go zip on your laptop, you zip a file. There's also more nonlinear or data-driven methods, which is what we're exploring now, in the hopes that this may be kind of the next evolution of faster data transfer speeds, so that what we call embeddings are transferred rather than the raw data or the compressed data. And the idea is that it can help distill just the information you need, and could even get to the point that you have different types of compressions for different tasks. So if, for example, you're interested in, I mentioned before, detecting flooded areas by satellite, there could be a way to extract an embedding for a task just like that, which would be very different to doing another task, which could be related to biodiversity, let's say, or weather forecasting. And so these are the kind of promising methods that we're really interested in exploring with partners and are exploring. And it requires this underlying technological infrastructure to make it happen. And so that's in combination with the ISR, it's this really wonderful opportunity to work with international partners and allow this to actually help communities.
I am interested to hear maybe from each of you a little more in relation to a specific climate-linked crisis or disaster or risk. If you would be willing to talk, even if it's hypothetical. I talked about scenarios. If you'd be willing to talk about an example, Matthew, I'm going to ask you that you talked about. I love the way you talk about how the applications that were used to be used for decision making were PowerPoint and Word document. And I'm wondering about if you could tell a story from your experience of trying to talk about a climate risk with decision makers, or hypothetically a specific one in which you found that the use of data was particularly helpful, or where it wasn't helpful. You could talk a little bit about how you can actually use it in trying to persuade decision makers to do the right thing.
Yeah, happy to. I would say the primary applications for decision making are still. It's not just that they used to be the PowerPoint, Word documents, and Excel spreadsheets, but that they are still those things. And to the detriment of the data that's getting into the decision process, kind of looking at the situation you just described, that immediately brings to mind kind of how we think about how we represent environmental thresholding revolving around decision making. From a risk-informed decision standpoint, whether it's military or any type of operational kind of decision, you're basing those around some kind of go, no-go criteria, and that can be a tiered approach. The military often represents these in stoplight charts, so like green, yellow, red. Often those are in like a tabular format. There's, they're laid out in a table, and with often broadly kind of non-specific references to like what area or what place are we talking about. And so that brings uncertainty just into the interpretation, and that's layered on top of a situation that already contains uncertainty to begin with. So we're trying to make decisions about forecast conditions which have uncertainty. We're not quite sure what the boundary of the area that we're talking about is. And then there's also the understanding of the person making the decision around their interpretation or their understanding of the thresholds themselves. So we're compounding all of these possibilities for kind of confusion or misunderstanding. Somebody sitting right next to another person might look at that cell from the table, that is saying, in this area, we recommend or we don't recommend you to do something. They can interpret that in different ways and to varying degrees. And that's for anyone that is doing all of the work on the back end that's been developing all these processes to know that the results of all that work might not even be understood or might just kind of get washed out by the way that the decision makers are interacting with the information or being presented the information. I think that that should be a call to arms for people to want better communication channels, want better communication systems, want better decision-making interactive applications or avenues, right? Other approaches, really. For us, we've really worked hard to move away from the tables. We've been developing, I haven't thought about them as like embeddings, but I mean, that's actually a really interesting idea of moving the kind of decision layer into actual decision surfaces that can be overlaid in a geospatial manner, kind of geospatially with temporal aspects, so we can show how the thresholds around those decisions are changing with time, where they are actually located, where the boundaries of that decision space are, as far as we are either able to calculate or represent, or as far as we're able to measure. That then gives us the ability to start doing layering and doing kind of more complex representation, where we can start building composite or aggregate representations of multiple thresholds, either for the same space with different considerations for doing multiple types of operations, multiple environmental parameters, or over a period of time. So, in this time block over this cell, are there any thresholds that are outside of favorable conditions or conditions that we would consider dangerous or would cause some problem that we are trying to avoid? And that's, taking something that could be very difficult to interpret and also forces the decision maker to try to do all these calculations and try to put it all together in their head and translate back and forth. And now, so we're trying to move that into the actual kind of space where the decision is revolving around.
So if I take some of that as kind of an optimistic view of how it can work, right, with the different stages and inputs of decision making, right? You're giving a scenario of some good going in a good direction of some good processes, I would think. I'm wondering about in other contexts, with other kinds of responses. And Danielle, I was going to ask you about wildfires. When you and I first talked about your modeling for wildfires, you said something that really stuck with me, which was that part of the context is that wildfires in and of themselves aren't all, they're not all bad. Fire isn't all bad. It's that it's when they're out of control, and it's when it's destructive. And so that's when you're looking at the modeling. Obviously, you're looking at is when it's when you need to fix something, when something's seriously dangerous and threatening and destructive. And so I'm wondering for you, what is successful? What is successful in terms of using the data and modeling that you do? What would be successful in being able to help with a response? What would be the outcome from that?
Yeah, in my particular case, I use physical models. So we are not based only on the data. We use the data as input or boundary conditions for the models. So yeah, in my research, we perform multiple simulations in order to get or evaluate some dangerous zones. So our approach is trying to use these results in order to make informed decisions, mainly for the experts in disaster management, maybe government institutions. So yeah, that's the main idea of our approach. And also we can use the models to create new data for AI-based models in order to complement the analysis. So yeah, I think the main contribution of the work in my particular case with wildfires is trying to help to the people who make the decisions, try to minimize the damage of the wildfires. So yeah, I think this is the main approach of our ideas or our application with this kind of models.
Campbell, can I kind of ask you the same question? Maybe in terms of floods, in terms of a specific disaster or crisis of
Yeah, sure.
Yeah, what works?
So yeah, so we've done a lot of work in looking at historical floods, for example, to ensure that the foundation model that we've developed works for, it retrieves some satellite data, and then it tries to detect the spatial extent of the flooded water, and then perform some analytics to extract the depth as well. Something that we see real challenges with that are maybe a little different to humanitarian crises, that is more local, where I'm based in New York City, is like electrical grid failures from flooding. So we can look at in Vermont recently, which is in the northeast of the US, there was widespread flooding from just a huge amount of rainfall. And that actually knocked down quite a lot of the power systems there. And these are events that are occurring more and more frequently. So having a way to firstly, quite accurately be able to detect the size of, say, a flooded area, and then combine that with some sort of forecasting model, that suddenly becomes a very, very powerful toolkit. And so, like I said before, I sound like a bit of a broken record. Building the technology that can then enable models like that to be built is what's really key, because different locations require different types of models, different types of inputs, different types of tuning and calibration. And so, if you can, have the community kind of agree on these are the standard approaches and sets of tools that we should all use, then we'll be in a much better place to respond to these types of events, which are unfortunately becoming more frequent.
Great. Well, I think that's a great place to leave on a high note of helping us have a better response and be in a better place for crises that we know, unfortunately, are going to continue to increase, and where hopefully all of the kind of tools that all three of you have been talking about today will continue to be more and more useful and more applied, that decision makers will be thinking seriously about them, and that they'll be able to be put into action bridging across the digital divide, and across different kinds of crises and different contexts. So thank you, all three of you. I appreciate you joining us today, and thank you so much.